Okay, welcome back everyone to the OrCAD X layout tutorial series. Again, my name is Adam Fuchs. I am a product engineer at Cadence Design Systems, and we are now at second pass routing on the board that we've been working on. Again, if you need to download this board, feel free to download the how-to_second-pass-routing.brd file. And if you've been following along with your own version of this board, please do continue to work on that. In this second pass routing, we're going to mostly be taking advantage of the slide command as well as selection features in the properties panel to make slight adjustments to the routing on our board. The best place to start generally when you're looking to make improvements or looking to fix issues is probably the DRCs in our design. As we've seen before, on the right side on our properties panel, we have this nice little overview of all the DRCs in our design. We have one design DRC in this case and 6 spacing DRCs. This pie chart is actually interactive, so you can click on the spacing DRCs, and if there were multiple categories, in this case we have line 2 spacing DRCs and SMD pin 2 spacing DRCs, you could continue to click down and navigate towards the exact DRC that you want to interrogate, or you can look at the top level and then use the search panel at the bottom to filter for what you're looking for. In this case, I can actually see that there's a couple bow ties, which is the DRC marker in OrCAD X layout. There's a couple bow ties already on my board, so let's go ahead and take a look at some of these. One thing I'm also going to do first is undo all of my color changes. Once I'm done with my first pass routing, I generally tend to switch back to the default layer colors. So to do that, it's just in the visibility, under the net section, and then there's a net colors clear all that I can click really easily, and that will go ahead and restore my default color. We can start to interrogate some of these DRCs. As long as you have this DRC selection filter turned on, as soon as you hover over it, you'll get a nice little tooltip that'll tell you what the error is. It'll highlight the two culprits. In this case, it's this via and this trace that we have here. And then I can also find the same DRC in our search table at the bottom here. If I go ahead and reset, you'll notice that the last tab in the default search results is always going to be DRC here. And I can click through by double clicking, navigate, and take a look at what these are. One thing that you may have noticed here, these DRCs are actually on the bottom layer. And so if I turn off my bottom layer, it hides the DRC bow ties. That's because the bottom layer here in my visibility actually has its own sort of selection for DRCs. So it can help with sort of controlling which DRCs are visible, which aren't. Now, to fix some of these, we're going to go into the slide command. Again, you can use manual or assisted mode, and in this case, we can simply slide the trace out of the way. Same thing, we can slide the trace slightly out of the way, and the DRC should go away. Our search results also are now only showing 5 DRCs. And we can continue to go through and solve some of these. Here we have via to through line spacing. In this case, I'm just going to move this via to the left side here. Let's see what else we have. I'm going to get to this section of the board in a little bit. I'm just going to go ahead and move this over here for now. And then this line over here can also get adjusted as well. Perfect. Now, one of the things that I was planning on fixing in the second pass routing is this 12 volts going through this current limiting resistor into this pin over here. Realistically, the same current is coming through this 12 volts trace as it is through this N46598 trace. So what we better do is actually adjust it so that the N46598 net is also considered a power net. Quickest way to do that, as I mentioned before, is to just go to Tools, Constraint Manager. We can make these changes on the fly. If I go into Physical, All Layers, rather than having to look through here, I'm just going to go ahead and turn on my net selection, select the N46598 net, do a right click and cross probe, and then we will see that Constraint Manager is automatically going to highlight that for us in the active worksheet. In this case, as I said, I just want to change the constraint set of that net to power. Now it's in the power constraint set. That normally doesn't trigger a DRC update. So you'll notice that our DRC now shows out of date. We can refresh that and you see we have a whole new set of DRCs to deal with. What I can do here is try to redraw this, but you'll quickly notice that we run into a small issue. So once I start routing this, I'll start in the auto mode and then I'll get into my neck mode to get closer into this pin. Let's just go to a finer grid. As we get closer to this pin, we start to get additional DRCs, in this case saying our line to line and line to SMD spacing is 0.1438 millimeters instead of the required 0.15. Now, we can't remedy this with simply, moving this trace around, because these pins, we can measure how far they are from each other by using the built-in measurement feature. To do this, simply hold down the left Alt key. You'll notice the board goes into sort of like a shadow mode. And then I can click two pins, and see that these pins are 0.17 millimeters apart, but these two traces, even if they're centered on the pin which they're supposed to be connected to, are 0.1460 millimeters. So I have two options. One is I can reduce the spacing requirements, but in this case I actually want to keep my 0.15 millimeter spacing. The other is that I can adjust the width of the neck for my power constraint set. That's probably the best solution for us. So I'm going to go down into Constraint Manager, find the power constraint set, and I'm going to change the neck width to, actually, I got ahead of myself. I'm just going to change the neck width to match the width of this pin. And I can find out the width of the pin simply by selecting it. And in the Properties panel, if I scroll down, I can see that the width of the pin is 0.2301 millimeters and the height is 0.6299 millimeters. So we'll go ahead and change the neck to 0.23 millimeters, and that should be enough for our requirements. So once that changes through, go ahead and refresh our DRC. Let's go ahead and delete this trace and redraw it with the new neck width. There we go. And the DRC is more or less gone. You might be thinking that, well, we went through a lot of effort in the previous phase of this layout, connecting all of these necks for the power pins on the main microprocessor, and they're all 0.254 millimeters wide. What is the quickest way that we can make that adjustment? Well, that is through leveraging the search panel. So if I go ahead and reset my search results here, and I go into my Traces and Wires tab, I can actually use the width column and filter to find all traces with 0.254 millimeter width. In this case, we have 12 results. If I do a right click and do a select on canvas, you'll see that it's all of the traces that are either connected here to this microprocessor or the power pins on this little connector that we have on the side here. Now I can easily change all of these values simply by doing a right-click edit in here, or since I already have them selected, I can also do the edit in the Properties panel right here. So if I double-click in this field, change this to 0.23, the change should go through. And now if I reset and select all of these again, you'll see that they are 0.23 millimeters throughout the whole design. In fact, if I want to, I can reset again and filter in ascending or descending order. If I scroll down, you'll notice that we don't have any more traces that are 0.254 millimeters in size. I did notice one trace here. This one seems to be 0.127, even though that's allowed. I'm just going to go ahead and fix that. Now I can just go through and start to clean up some of these traces. I'm not going to do all of them right now because that would take quite a while, but just enough to where I'm comfortable saying that we can move on to editing some of the shapes on this board. So we're going to go into the bottom layer. Let's see, this is looking okay. That's looking okay. Nothing standing out to me right now. Okay, so this we can definitely make better. When you're in the slide mode in assisted, you have the option of hugging or shoving. What that means is if I try to move this trace, it's going to hug around the via, versus if I have shove turned on, it's going to shove that via out of the way if I have the shove vias checked on. I personally like to stick in the hug mode. What we're going to do here is just move this trace a little over and route this one right through here. Now, even though we said in an earlier video that these aren't the differential pair, I'm just going to couple these closely together as if they were. And then on the top layer, this is looking fine, and that's looking okay. All right, let's see. I think everything on the bottom layer is more or less looking good. Top layer, we can go through and maybe fix up some of these. We're going to place some shapes here, so we're not going to worry about that for now. So here, normally, some designers might scoff at this as it's kind of a Y point. We can go ahead and actually retrace this. Oops, we were in neck mode. Let's undo that. One thing I also want to mention is if you have both trace segments and traces turned on and you hover over a trace segment, use the tab key to switch over to the next available selection. So in this case, it's selecting either a trace or a trace segment. So now I can just select the whole trace and delete it rather than deleting it segment by segment. Okay, let's reroute that. We're going to go to our auto trace width. And then we're just going to slide this a little bit. If the tool is not necessarily behaving exactly as you would expect it to in the slide mode, try adjusting the smoothing slider. Smoothing is basically going to try to take out as many notches or these little steps as it can to try to make it as smooth of a trace as possible. Sometimes just turning off smoothing can help you achieve the desired trace that you might want. Okay, so things are actually looking pretty good here. Maybe we just clean these up a little bit. So now I'm going to fixate on all the little things that I can change or edit. So we've gone through and made some changes to the layout of our board using the slide command. One thing that we might also want to do is, in the case of this, for example, switching regulator, rather than using traces, we want to add a shape. To add a shape, simply, as you've seen before, use the add shape command. What we want to do, and let's go ahead and color it, We want to create a shape under this switching regulator IC so that there's a very short and quick return path for the currents flowing through here. And in order to do so, we're going to have to trace out some complex geometry with the shape tool. We'll go into the shape tool, we'll select polygon, layer top, dummy net. We can scroll down to ground, or we can just use this eyedropper to select the net simply by clicking on the canvas. If you want to, you can turn on the grid to help you with drawing or visualize where you want to draw the shape. And then simply just start clicking on the canvas to draw a shape. I'm going to add a couple lines here. Now, we can always edit the vertices and the different lines of this polygon after we've created the shape, so you can be pretty rough with your first pass of the drawing. So now that we've created the shape, as long as we have it selected, you'll notice that we have all these little points. This is basically little vertices that we can move around to adjust the size of our polygon. If it's a rectangle, right, it'll change the size of the rectangle. Notice the little tooltip at the top right. It says remove vertices is on, press T to preserve corners. So there's a lot of different options. Likewise, if you select the point between two vertices, it'll move the whole line instead of a single point. And then also, if you go into shape utilities, there's also options to resize. There's Boolean operations if you want to merge two shapes together, or take the and or the nor of two shapes. You can also trim corners, a lot of options for shape editing. In our case, what we want to do is we want to select this shape and take a look at some of the properties that are available. In our case, by default, you can see that we have some thermal reliefs that got added to these pins. In the case of this pin here, there actually wasn't enough space to add a thermal relief on the left side. And so we might want to adjust how the thermal reliefs behave either for this shape or the individual pins. To do that, go ahead and scroll down. There's a section called thermal reliefs. You can set the thermal reliefs either for all objects or for SMD pins, through-hole pins, and vias individually. So right now we have SMD pins need to be orthogonal thermal reliefs, minimum of 2, maximum of 4, and the width is going to be the constraint width. So in this case, these are going to be 0.9126 millimeters. So pretty, or I'm sorry, that's the length. These are probably 0.508. Yep, 508. So we're going to go ahead and for SMD pins, again, just for the sake of time, we're going to change it so that all of the SMD pins on this device will connect with full contact, like so. Then another thing that we can do is also select individual pins and change their thermal relief type, which takes precedent over the shape. So the shape is a more general assignment of thermal relief, and the pin can be more specific. So here in this case, we can set this to orthogonal. We can set the width to, for example, user defined and say 0.254 millimeters. And then we would have these two orthogonal thermal reliefs. Plus, this is actually a trace that we drew earlier. We're just going to leave this away for now. Shouldn't have too big of an impact on our circuit. And then let's just draw a couple other shapes here. So we're going to draw a shape on the top layer for 12 volts. Okay, so now that we have two shapes, you'll notice that the way that these are drawn is actually determined by default the order in which they were placed. If I want this shape to take priority, by selecting it, I have this option for selecting the priority. I can either increase or decrease the priority and then on the canvas you can automatically see the changes between the two. So which one has more priority. In this case, I actually want my ground to have priority. And then let's see if we want to add any other shapes. Not by default. We're just going to go ahead and change some of these to some thicker traces. Now, normally you can select auto constraint neck. You can also type in a value here. If I change this to 0.8 millimeters, for example, not a problem. Let's change this to 0.06. Not a problem. And here we have some ERCs. So we can actually add this net to our power constraint set as well, and that should resolve the issue. Let's go ahead and launch Constraint Manager. Select nets, cross probe, and let's add it to power. One other thing I want to mention really quickly is if you don't want to do the right-click cross probe every time, at the bottom left here, there's this option for auto cross probe. Basically what it means is anytime I select something on the canvas, it'll automatically do a right-click cross probe in the background for both Constraint Manager and also the schematic if that's what we need to access. In this case, it looks like, oh, there we go. So cross probe to the plus 3.3 volt power net. And I'll cross probe to ground. Yep, it's working as expected. Okay, so the only other thing that I want to do here is add some vias. Let's go ahead and add some vias. There's a couple options for this. One is you can simply click on a via, copy it, and then start pasting it around where you think that you need to have vias. The other option, I'm just going to use Control Z. Oops, let's go ahead and close Constraint Manager. I'm going to use Control Z to get rid of these. And let's get rid of this one as well. The other option is to use the via array command in OrCAD Layout. Before I place a via array, let's just make sure that we have this shape all refreshed and good to go. On the properties panel, it'll say that we have one out of date shape. I can either click the blue link to see what the shape is, or if I just click on the refresh, it'll automatically refresh that shape for us. Let's click on this shape. You'll see that it is now up to date, and if it was out of date for any reason, we can also just click it in here, I believe. Okay, so we're going to use the via array command. Via arrays can be used to either create stitching vias across a whole board, place vias around a trace for signal integrity requirements. What we're going to use it for is just to place a bunch of vias inside this shape. And we have options for, radially placing them around, for example, another via across the whole board, like I mentioned, in a drawn window. In our case, we just want to say shape. We're going to choose the net as this 12 volt net. And then we can choose the offset between the vias. I'm going to set it to 0.5 millimeter. Now click on the shape. And then we should be able to click on shape where we want those to go. Not ideal, could be better. in this case, I was just using it as an example to show how the feature works. Let's go back into that VArray command. I'm just gonna remove all of these vias here. Delete. And let's go ahead and just place them manually by doing some Control-C, Control-V work. Okay, and then we can also add some vias to this ground, so we can stitch it with the layer 2 and layer 3 grounds. One other thing that you can do when working with shapes is simply copy shapes. In the previous video, we made this shape on layer 2 for the grounds. I can select this shape, do a right-click copy, and then do a right-click paste special, and it'll ask me what layer I want to paste it on. So we're going to choose layer 3. And then for snapping, we want to snap to ideally, we'd want to snap to the same shape. And it did. Perfect. If you look at the out-of-date shapes, again, you can click on this to see which they are. It's the ground shape on layer 2, ground shape on top layer, and the 12-volt conductor. And this is because these have vias going to that ground layer, so that's why it's going to ask us to update each of them. One of the things that shapes can run into is islands. If we look at this shape islands and click on the blue link, we'll see that there's a couple areas where our shapes have these conductors that should have a net, but realistically they're not connected to anything, mostly because of the voiding rules around the pins, which they're, enclosed in. So the quickest way to delete those islands is to simply click the red X in the properties panel. And that will get rid of both the layer 2 and layer 3 island, so we're good to go. Okay, we're gonna go ahead and just copy and paste a couple more vias in here, or we can also use the via array option. I'm gonna go to via array, window, 0. Let's do 1 millimeter this time, as the 0.5 was a little too small. I'm gonna change this to the ground net. Pick our pin here. And we're just going to draw this. There's a nice array of vias on our E-pad. Volts unrouted. Oh, that's right. We to make sure that this 12 volts is still connected to this. Let's go ahead and add a shape on the bottom layer. We're just going to do a rectangle this time. and then simply connect this trace into our polygon. All right, that should take care of that issue. Then we should only have one DRC at this point, which is, yep, the package to place keep-in on the top layer. We'll talk about that in the next video. Okay, so thanks for watching. This was second pass routing where we did some additional editing of our layout. We added some shapes, we added some stitching vias. We slid around some traces just to make sure that they're looking good. And yeah, see you in the next video where we're going to take a look at the additional DRC options, the 3D view, and also maybe talk about doing some silk screening.